Hi, in this video, let us know more about Kubernetes. Kubernetes is an open source container orchestration platform, allowing large number of containers to work together in harmony, reducing operational burden. It helps with things like running containers across many different machines, scaling up or down by adding or removing containers when demand changes, keeping storage consistent with multiple instances of an application, distributing load between the containers, and launching new containers on different machines if something fails. So it's an orchestration platform for containers. Now let's take a closer look into the Kubernetes architecture and see what is happening behind the scene. So this is the Kubernetes architecture. Uh, on the left hand side of the diagram, you have the user interface as well as the CLI, which is the kubectl. So these are basically used to interact with the Kubernetes cluster. We'll see in this course how to interact with these tools. Okay, now moving on, we have the Kubernetes master as well as the worker node 1, worker node 2. And you can go more than worker node 2. It can be n number of nodes, doesn't matter. But in this example, we just have 3 nodes. One is the Kubernetes master and the other two are the worker node 1 and worker node 2. So these 3 together forms a Kubernetes cluster. So in our case, in this example, in our course, we have a Minikube cluster, which is a 1 node cluster, which has a master as well as the nodes all combined in a single cluster. But here, in order to explain you the architecture, we have this kind of setup. So moving forward, in the Kubernetes master, we have 4 components. The first component is API server. It is used to perform administrative tasks for the cluster. And the kubectl CLI as well as the user interface actually connects with the API server to make changes to the Kubernetes cluster as a whole. Next is the scheduler. Scheduler work is to schedule work to different worker nodes. So like creation of a pod or a container on a different worker node, that is the work of the scheduler. Next is the controller manager. So controller manager actually makes sure that the current state of the cluster is same as the desired state. So what I mean by that is, like, if you have like a container running on this cluster, like the desired state of that application is to run 3 containers. So controller manager will make sure that 3 containers always run on that Kubernetes cluster. And if a container fails, it will just bring up a container in any worker node and it will schedule it to a pod. So that way our application keeps is up and running all the time, and we don't have too much worry about that part. So, and the last one is the etcd. Etcd is a distributed key value store which is used to store the entire Kubernetes cluster state. So these 4 are the main basic components of the Kubernetes master node. And from Kubernetes master node, we can connect to other worker nodes. So it operates on different worker nodes. Main operation happens from the Kubernetes master to the worker nodes. Moving forward, we have the worker nodes here, and the main components are the pod, the kubelet, and the kube proxy. So what is a pod? A pod is a scheduling unit in Kubernetes. It is a logical collection of one or more containers which are always scheduled together. So you can see One of our application can be a container. uh, so for example, in this course, our Go API will be a container, then our Postgres database will be another container. So it will get scheduled, it will get scheduled in a pod of a Kubernetes cluster. And moving on, we have the kubelet. Kubelet receives pod definition and runs the container associated with the pod, and also it makes sure that the containers inside the pod are healthy. So that's the basic function of kubelet. So from the API server, all the pod definition goes to the kubelet, and the kubelet makes sure that the container is running properly, it's healthy. That kind of thing happens using the kubelet. Next is the kube proxy. So kube proxy is, instead of connecting directly to pods to access the application, we use a logical construct called a service as a connection endpoint. A service groups related pods, and when it accessed, load balances to them. Now kube proxy is a network proxy which runs on each worker node and listens to the API server for each service endpoint creation and deletion. For each service endpoint, kube proxy sets up the routes so that it can reach to it. What do we mean by this is like, if you want the external world to go and access your service that is running inside a pod, it will happen using the kube proxy. So that's the basic working of a kube proxy inside the worker node. So these are the main components of a Kubernetes cluster. So that's how the Kubernetes architecture is defined, and these things happen behind the scenes.